4.3 is all about adding and subtracting polynomials. So let me show you the entire steps for adding and subtracting. Now we got to take this section in two parts. First part that we're going to deal with is where when we add and subtract, we're going to have those like denominators, that common denominator. Okay, because if you can understand how it works with common denominators, once we get to finding the common denominators, it'll be smooth sailing. Okay, so with this, just like when you have with fractions, like 1/2 plus, excuse me, 3/2, we've got that common denominator. All you do is you add across the top. You put like terms together across the top, which gives you 4/2. And then from there, that's when you simplify down. Adding and subtracting polynomials will work the same way. We're going to make sure that all denominators are factored. Okay, and that's going to help us determine that we have the proper common denominators that we need. Then all we're going to do is add across the numerator, like what we did with the 1 and the 3. Again, you leave those denominators alone. See, it was 2, 2, and my denominator over here was 2. And from there, you will factor the numerator and then do any simplifying and write down what's left. Okay? Adding and subtracting polynomials is just like adding and subtracting fractions. All right? So let's go do some adding and subtracting. So again, in your assignment, the first few examples are all going to be ready for you. Notice you already have that common denominator right there. Okay, we already got x and x. So my polynomial will have x on the bottom. Let's get out of this mode, page width. And then all we do is we combine across the top. 5 plus 3, 8. Is there any factoring? Just like what I told you in 4.2, as long as you have single terms, there is no factoring. So is there any simplifying then? No. So this is the final answer. See, not too bad, right? Let's do another one. Go ahead and pause the video. Give this one a try. Okay. So you can already see we got that common denominator. So we're going to leave it alone. Then all we're going to do is combine like terms across the top. Well, this is 2x and this is 15. Can I really subtract those two? No. So there's no combining like terms up there. So what we have is 2x minus 15. And now we're going to see if there's any factoring. Can any of these, can this numerator or denominator factor? No. So from there, is there any simplifying? And remember that we cannot simplify these x's. We can't take them out because this is a part of a family up there. Remember, we cannot take out families unless we're taking the whole thing out. So unless I have a 2x minus 15 down here, there's nothing that's going to take out that 2x minus 15 up top. So this would be the final answer. See, pretty straightforward, right? Let's do, I believe this is my last one. Nope, I got one more after this. So go ahead and pause the video. Give these two a try. Be careful on this guy right here with the subtraction. So go ahead, pause the video, give it a try. Okay, so let's go back to our normal view over here. Hopefully you gave them a try. So we've got that common denominator. And notice I haven't been worrying about factoring on any of these because this bottom part right here, it is factored. Okay, and this one we will do some factoring on for that denominator, but they're going to be common denominators anyway, but we need to do the factoring because that's going to help us simplify later on. Okay, so we're going to write down our denominator, x minus 6. And then across the top, what's going to get together? Well, this is x squared. This is x. That's a 42. None of these are going to get together. They're not like terms. So we have to write them all down. Okay. And from here, Now we have to make sure that everything gets factored because we've done the adding subtracting. See, the adding subtracting is not that bad. So we need to make sure this numerator is factored. The denominator we already talked about. I just said a moment ago, it already is factored. Okay. So x minus 6. And so in the numerator, remember you got to use your factoring skills for that. Okay. And this guy will factor to x plus 7, x minus 6. So is there any canceling? You bet. The x minus 6 up here, the x minus 6 right there, cancel out. Okay. And what do we have left? We have x plus 7. Again, in here, you might have a spot where they ask you what the numerator is with a box, what the denominator is with a box, and they want you to fill these in. Because our denominator canceled completely out, this guy really is over a 1. Excuse me. So if your denominator cancels out, there really is a 1 there, and the numerator was x plus 7. And the same thing goes with the numerator. Had my numerator all canceled out, then there would have been a 1 in that place. So just know that anytime everything cancels out, you're going to have a 1 in its spot. Okay? All right, so let's go ahead and factor this stuff. Make sure that these truly are common, even though you can see that they are the same denominator. In order to factor these, all we got to do is pull out a GCF. So we're going to pull out an x, and that will give us x minus 7. And the same thing over here, pull out an x, that will give you x minus 7. So yeah, they truly are, if you look at them as factored forms, they are the same. Okay? So we're going to put our line, put our x minus 7 on bottom. And now this is the one I told you to be careful of, and it's because of the subtraction with everything that's going on right here. Subtraction is the one that you have to be careful of, because whatever follows the subtraction, what's really happening, it's like it's taking a -1 times everything that follows. Okay? Or you can think about really what subtraction does is it changes all the signs. Okay? So we got x squared from here. What does a positive 2x become? A negative 2x, because we're subtracting all of this. What does a positive 35 become? A negative 35. Okay, so whether you think about it as distributing a -1 through there, or whether you just take what I just said, whenever you're subtracting and you got a lot of information that follows after the subtraction, all you have to do is change the signs. So here's what we know. Okay, so now we do just like what we did a couple of seconds ago. We got to make sure this numerator gets factored. And it does factor to x minus 7, x plus 5. Okay? Oh, I was trying to erase this piece. There we go. All over x minus 7. So is there going to be any canceling from top to bottom? You bet. The x minus 7 cancels out the x minus 7 down below. And our final answer is x plus 5 all over x. And there you go. That's adding and subtracting when you have common denominators. And that's how your assignment's going to begin out. Okay? Now we're going to switch and we're going to focus in on unlike denominators. But before we get to unlike denominators, we need to talk about the key concept of the LCD. Okay? LCD stands for least common denominator. Okay? And so what we want to do is I want to do a couple problems. I believe I have 4 of them here. Yep, 1, 2, 3, 4. Okay, I've got 4 problems where I want to work on finding the least common denominator, because now that we're dealing with polynomials, it's a little different than when you were trying to find the least common denominator between like 1/3 and 1/2. Okay, there it's just numbers. Okay, so I want to talk about what do we do with polynomials. All right, so this is going to be very, very important for us. We are dealing with least common denominators in 4.3, 4, 4, and 4, 5. So I need you to be able to do least common denominators. That's why we're going to spend a lot of time on this. And hopefully by the end, you're going to be very, very good at this. Okay? So when I talk about the least common denominators, how I approach this is I say, look at all your denominators. We got 2x, 8, and 3. We don't care what the numerator's doing. We just care about finding that least common denominator. Okay? So to find that least common denominator, here's my trick for you. Okay, the least common denominator, you're going to hear me say this a lot, it has to be made up of everybody that's up here. Okay? Has to be made up of everybody that's up here. The 2x, the 8, the 3. So when I start to find my least common denominator, the very first thing I'm going to do is I'm going to write down my first denominator, 2x. Because like I said, it has to be made up of everybody that's up there. Okay? So my first denominator, 2x, is definitely covered by 2x. But when I move to my second denominator, does 2x cover 8? No, because there's not an 8 embedded in here. Okay? So what can I do to change this 2 to a number that will cover the 8? Well, I can change the 2 to the number 8. Because 8 will cover 8. And 8 will cover 2 because 8 is made up of 2 times 4. So you see how the 8 contains the 2 in it? Because 2 times 4 makes 8. And 2 is one of the numbers I have to cover. Okay? So now I know that the 8x covers 2x. I know the 8x covers the 8. Okay? Now does 8x cover 3? No. So I got to adjust. How can I make 8 cover the 3? Okay. Well, we can come in here and change this 8 to a 24. Reason why? Because 8 times 3 makes 24, right? So there I now have the 3 covered. And I have the 8 covered. And we also know that 8 is made up of 2 times 4. So now I still have the 2 covered. So this is the least common denominator that we would turn all these fractions, 1 over 2x, 1 over 8, 1 over 3, into. More about that later on. Okay? So there is the least common denominator. Go ahead and give this one a try. Pause the video. Again, remember, we don't care about the numerator. It's all about the denominator. Try and find me the least common denominator. And go. Okay. So, if we look at all of our denominators, here they are. Again, using my trick, I start with the first denominator. Okay, write it down. Does x cover x? Absolutely. Does x cover 2 or x squared? No. Okay, so now how do I fix x so that it will cover x squared? Well, let's make it an x squared. Because in order to cover x squared, I got to have 2 x's. Okay? So if I make this x squared, that definitely covers x squared. Does x squared cover x? Absolutely, because there are 2 x's here. In order to cover this guy, I just need one of those. Okay? So x squared definitely covers x, and it definitely covers the x squared. All right, so now we move on to the next one. Does x squared cover x cubed? Well, again, x cubed has 3 x's. This only has 2. So what do we need to do? Bump it up a notch. Okay? So does x cubed cover x cubed? Absolutely. Does an x cubed cover x squared? You bet. I've got 3 x's. I only need 2 of them. Does x cubed cover x? You bet. I've got 3 x's. I only need 1 of them to cover that guy. And then last but not least, does x cubed cover 5? No. So that just means we need to add a 5 in front of my x cubed. And there is the least common denominator. Okay? Because this covers everybody up there. It's made up of everybody. All right. So again, on this one, let's talk through here. Just like in our directions, you got to make sure everybody's factored. So this is x minus 4, x plus 4. Okay? So you now know what your denominators are. We need to find the least common denominator, the LCD. So again, using my trick, start with the first denominator right here. Write it all down. All right, and there we go. So does x minus 4, x plus 4 cover this? Absolutely. Does x minus 4, x plus 4 cover x plus 4? You bet. I have x plus 4 here, and I have an x plus 4 there. It's covered. Okay? So what's the LCD? You're looking at it. It's this guy. X minus 4, x plus 4. And it is made up of both of them. Okay? Both of these two parentheses make the first guy. This last parenthesis makes the last denominator. Okay? So both of these denominators that are up here are right here. Okay? Let's do another one, just LCD, and then we'll start talking about adding and subtracting fractions. Go ahead, pause the video, give this one a try. Okay, so right here, this is x plus 1 and it's squared. Remember that if you have a power of 2, that just means we have 2 of these, so you do want to expand that out. Okay, it is so much better to look at it as the 2 parentheses instead of the 1. Make sure that you factored this guy, x plus 1, x plus 2. Okay, and this denominator is good the way it is. So here's our denominators. When we find the LCD, again, using my rule of thumb, start with the first guy. X plus 1, x plus 1. So does x plus 1 cover x plus 1, x plus 2? Well, the x plus 1 is covered right here, so that's good to go. So I've got the x plus 1s covered, but notice there's no x plus 2 down here. Okay? So since there is no x plus 2 down here, and as I said earlier, it's got to be made, the LCDs has to be made up of everybody, let's add in an x plus 2. And see right there, you can see all the denominators. Let me show you. Oops, don't want that one, I want the cover. So right there, x plus 1 covers the first guy. And then right over here, x plus 1, x plus 2 covers the second. See how that LCD is made up of everybody up there. All right, so does x plus 1, x plus 1, x plus 2 cover the x minus 7? Nope. So since it's missing down here, all we're going to do, add it in. And this is the LCD for those 3 rationals. Now, I know this has 4 of them in it. The most we will work with is 3. But I just wanted to cover LCDs with you and being able to identify, what's going on. Again, the LCD has to be made up of every denominator up there. And this denominator, this LCD, has everybody in there. Again, let me show you. There's the x plus 1, x plus 1. Okay? If I slide over here and pretend like this guy doesn't exist, let me just black it out real quick. There's the middle denominator, the x plus 1, the x plus 2. And then if I just come over here and then get rid of what I just made there, that little box, slide it down here. Hey, there's the x minus 7. See, every denominator up here is in this picture. Okay? All right. So let's start talking about how do we add and subtract unlike denominators? So here's the full gambit. Again, I know these look like a lot of steps, but this first piece right here, step 1 through 2, that's what we were doing a couple seconds ago, finding the LCD. This is where we're going to manipulate our fractions to become common denominators right here. And then the rest of this is adding and subtracting like what we did right at the beginning of this lesson with those 4 examples. Okay, so these first 3 parts are really about the LCD. And then the last part, once you have the common denominator, this is just like what we did a couple seconds ago. Okay, so I have 5 examples here, and I'm going to work a lot of these examples all at the same time. I would do this in class with you so that you can see everything all at once, and so that I can get you used to doing the steps. So 3 of these I'm going to work together, and then there will be 2 of these that I'm going to let you finish up and have you pause the video on, and then I'll show you the final answers for them. Okay? So go ahead and get these written down. Give yourself some space for them. And let's get started. All right. So the first things first, we know we do not have common denominators, and we got to find those common denominators. So our denominator is x and x squared. Those are the 2 denominators we have. So let's find that LCD. Okay. So I'm going to write down my first denominator. It's x. Does x cover x squared? Nope. We've already talked about that a couple seconds ago. So that just means I need to make this an x squared, because 2 x's cover 2 x's, and 2 x's can cover 1 x. So all I'm going to do now that we have found that common denominator, okay, and we didn't have to worry about factoring. They were all single terms. But if my denominators needed to be factored, we would have done that. So now we're going to multiply all the rationals by the missing piece of the LCD, okay? So let me show you what that looks like. We're going to manipulate these to both become x squareds on the bottom. We know that that's going to happen, okay? So here's my denominator. Here's what I need. I need the x squared. Well, what do I have to multiply this by to become x squared? That's what I mean by the missing piece. What is missing from this to become x squared? And if you said multiply it by x, you are correct. And if we multiply the bottom by x, we have to multiply the top by x. That's the missing piece that was missing from this denominator. So what's x times 1? X. Does this guy, x squared, match the x squared? You bet. So do I have to multiply this by anything? No, it already matches. If your denominator already matches, then you do not need to multiply the top and the bottom by anything. Okay? And there is the top piece for that second rational. And then now you just write back to what we did a couple seconds ago. Denominators already match, so I've got x squared in the denominator. Okay. Across the top, we combine like terms, but x and 12 do not get together, so I have x minus 12 on top. Anything factor? Nope. These x's will not cancel because it's a family up there. Because of the subtraction, the x and the 12 are together. So that is the final answer. See, not bad, right? All right. So let's work some of these together. All right. So here's another one. Our denominators are 5, 6x, and 2x. So let's start talking about, and let's go back to page width. I like page width. The LCD. Okay. So I'm going to start with my first denominator, 5. Does 5 cover 6x? Nope. So the only way to cover this x is to add an x down here, but the 5 definitely doesn't cover the 6. So what number can I turn the 5 into so that it will cover both the 5 and the 6? And that will be 30. Okay? Because 30 is made up of 5 times 6. See? Both are covered. So 30x covers 5. 30x covers 6. Does 30x cover 2x? Absolutely. Because 30 is made up of 5 and 6, as we talked about a couple seconds ago. But the 6 is made up of 2 times 3. See, the 2 is already covered in there because of the 6. So 30x is our LCD. So all of these are going to turn into a 30x. All right. I want to stop this problem there. I want to go and look at the other problems again, just working the LCD part. Okay. I think this is one of them that I skip. Yeah. So let's talk about this big guy. Okay. Again, we got to make sure everybody's factored now. Okay. Just like in the last one, there's a little bit of factoring on here. Okay. So this guy right here factors to x plus 4, x plus 3. Okay. So if we're thinking about our LCD, our denominators are x plus 4 and x plus 3. Those are all the denominators. Okay. So LCD. We're going to write down our denominators. Okay. X plus 4, that's the first one. X plus 3. I mean, I guess if you really want to write down the other ones, x plus 3 and x plus 4. There we go. So does x plus 4, x plus 3 cover x plus 4, x plus 3? You bet. Does x plus 4, x plus 3 cover x plus 3? Uh-huh. See, just like what we did earlier. There's the x plus 3. Does x plus 4, x plus 3 cover the x plus 4? Yep. So as I slide over to show you that real quick. There we go. There's the x plus 4. See, everybody, all these denominators are covered with just that. Okay? So all of these are now going to have a denominator of x plus 4, x plus 3, plus x plus 4, x plus 3, plus x plus 4, x plus 3. Okay? And again, we're going to come back to this guy. This one is going to be one that I want you to try on your own after we see these other guys. Okay? So, and this problem will be a lot like this one right here. All right? So let's go back to this one. Okay? So we've got the LCD here. So let's start fixing all of our rationals up here and multiplying by the piece that's missing. Well, what times 5 will give me 30x? A 6x. That's what's missing from this. Okay? If I take 6x times 5, I get the 30x. So if I multiply the denominator by 6x, I got to multiply the numerator by 6x. Okay? What times 6x will give me 30x? Well, this guy just needs to be multiplied by a 5. Okay? Because that's the part that was missing that transforms it into 30x. And then last but not least, what's going to turn 2x into 30x? We're going to multiply this by 15. Okay? So let's get our new rationals. 6x times 2, 12x. 5 times 1, 5. 3 times 15, 45. And now you're right back to what we started with at the beginning of this lesson. Let's go over to our guy right here. So here's my denominator, x plus 4, x plus 3. Here's what I want, x plus 4, x plus 3. So they match. So there's no changing to this guy. We don't multiply this first one by anything because the denominators already match. All right, moving to the next one. This one has x plus 3, but I need x plus 4, x plus 3. So what is this missing? This is where that idea of multiply by what's missing really shines through. This guy's missing the x plus 4. So we're going to multiply this by x plus 4. Both the top and the bottom, because that's what's missing in this denominator, the x plus 4 part. Well, now if you look at this guy, I have x plus 4. I need x plus 4 plus, or x plus 4 times x plus 3. So what's missing? Just like what we saw a second ago, it's missing the x plus 3 this time. So now we can go through and figure out all of our new numerators. So the first one stays as a 2 because the denominator already matched. And this one, you need to make sure that you distribute through. X times x is x squared. X times 4 is 4x. And then on the bottom, the last one, you got the 1 that distributes through there, but that's not going to change anything. And you're going to have x plus 3. And there we go. Okay, now again, we're right back to what we did a moment ago. Okay, so let's go back to that 30x problem and let's finish this thing out. Okay, so we're going to put like terms together across the top. So that means the 5 and the 45 are getting together. So we'll have 12x plus 50 all over 30x. Okay, and so now we factor the numerator and the denominator if it can. Well, the denominator can, it's a single term. But there is a GCF in the numerator that we can pull out, which is 2, which will leave us with 6x plus 25 all over 30x. And is there any reducing? Absolutely. The 2 and the 30 can reduce each other. Okay, because this is not a family down here, and the 2 is not a family. There's no addition or subtraction with those. So 2 over 30 reduces to this final answer. 6x plus 25 all over 15x. And that is the final answer. Okay? Nothing else can happen. You can't reduce the 6 and the 15 or the x's because, again, the 6x is a part of that 25 with the addition. That's a family up there, so you can't touch those. All right, so let's get to this guy. So the 2 and the 3 are going to get together, and the 4x and the x will get together. So I'm doing 2 circles. So what we have then in the numerator is x squared. 4x plus x is 5x. And 2 plus 3 is 5. In the denominator, we have x plus 4, x plus 3. And then now, last but not least, you try to do any reducing that we can. Is there any reducing? No, because this x squared plus 5x plus 5 does not reduce at all. It does not factor. Okay, so that is an answer. Or if you want, again, like I told you in the multiplication one, if you want to FOIL out the bottom, the denominator, and call it x squared plus 7x plus 12 and have that as your answer, both of these are absolutely A-okay with me. Okay? All right, so I had 2 that I didn't touch in here. Again, I want you to give those a shot. So I gave you this one. And there's one more. There it is. Go ahead, pause the video now that you've seen how to add and subtract fully on 3 problems. Give these a shot. Okay. So, oops, deleted the page. Undo. And let's go back to page width. Oops, single page. So in here, first things first, we have to factor this. And it's just a GCF. Pull out an x minus 4. Okay? So our denominators are x and x minus 4. So if I'm thinking LCD, hopefully you're getting better and better at this by now. The LCD should be x and x minus 4. Because this x covers that guy, and the x minus 4 covers the other denominator. So x minus 4 minus x minus 4. Okay? So here's what I've got, x. Here's what I want, x minus 4. So what's missing? You bet. X minus 4. X minus 4. So we take and we multiply the 1 through the entire numerator, and we get x minus 4 on top. Here's what we got. Here's what we want. Oh, they match. So leave the numerator alone because they matched. Okay? So now all we have to do is combine like terms. The x is getting together with the x, and they will subtract. So x minus x cancels itself out. So what do we have left on top? Negative 4 all over x minus 4. Is there any factoring in the numerator? No. Is there any reducing? No. Remember, we can't touch those two. This is a family right there, so no canceling. Okay, so that would be the answer. Or if you wanted to multiply out, this is perfectly fine too. X squared minus 4x. Both of these are valid answers. One more problem, and that wraps up 4-3. So all these need to be factored, these denominators. This factors to x minus 3, x minus 1. This guy factors to x plus 4 and x minus 3. Okay? So our denominators are x minus 3, x minus 1, and x plus 4, x minus 3. So if we're looking for that LCD, I'm going to write down my first denominator, x minus 3, x minus 1. So does x minus 3, x minus 1 cover this guy? No. I mean, I've got the x minus 3s, but I'm missing the x plus 4. So I need to add an x plus 4 onto this. So this is what I was saying a couple minutes ago. This is the biggest that you're going to be dealing with. This is as hard as what these problems get. So my two fractions have a denominator of x minus 3, x minus 1, x plus 4, x minus 3, x minus 1, x plus 4. Okay? So, here's what we have. Here's what we want. What's missing? The x plus 4. So this guy's got to get multiplied by an x plus 4. So does the numerator. Okay? So if I distribute the x through, x times x squared, x times 4 is a positive 4x. Okay? Over here, I've got x plus 4, x minus 3. This is what I want. So what's missing? I need to multiply this by x minus 1, both on the top and the bottom. So 19 times x is 19x x. 19 times negative 1 is negative 19. And there's what our two rationals look like. So now all we're going to do is combine like terms. So our denominator stays as x minus 3, x minus 1, x plus 4. Again, be wary of the subtraction. It changes everything in here, so hopefully you caught that when you were going through. So up here, the x squared, the other thing that you can do, since you know that it changes everybody, you can just turn this into a plus now and change these signs. The positive 19 becomes negative. The negative 19 right there becomes a positive. So you can do that too. So no one's getting together with the x squared. Okay. The 4x is getting together with the negative 19x. So that gives us a negative 15x. And then no one's getting together with the plus 19. So there's a plus 19 there. And so now you look and see, can the numerator factor? No matter how hard you try, that numerator will not factor. So thus, there's no canceling. There's no simplifying. So that is the answer. If you really want to multiply the denominator out, by all means, go ahead. I'm not going to do that, okay? But it will be a cubic polynomial that you'll have there. But this is good enough for the answer. And that is 4.3.